So here we have the two devices. Let's try and send data to the 52 series. I'm typing something and then sending to the 53, and the 53 receives it. Now the opposite direction is nothing. So let's troubleshoot that using a general coding agent. For here, we'll use Claude Code to make it comparable to our tool. We'll be both configuring the tools with the cost model, which is Haiku. So we will use the same model with Claude Code and the Adsum IoT Coder that we'll see later. Okay. So here we will start with a prompt. Because this is a general agent, we will describe everything in the prompt. So debugging a Nordic NRF 50X firmware project with NRF Connect SDK. The boards are connected via G-Link and so on and so forth. One thing to highlight is listing explicitly that you have access to the Nordic MCP to help you with the debugging tasks, explicitly telling him that it's configured, it's there, you can use it. So that's an additional advantage for the general agent tool. Plus, I'm giving him some instructions so to make it easy for him to follow the flow. He can follow those instructions, or he can bypass them with his own intelligence. But you capture the logs, analyze the logs, fix the code, build and flash, capture the fresh logs again to confirm the fix, and then give me the summary. So it's almost a similar workflow that we in general have in Adsum IoT Coder. So to be able to compare them and be fair between the two models, I'm giving them almost the same instructions. So here we go. Let's start. The Nordic MCP server, as you see, Nordic search sources, how to use RTP, getting into the right direction there. And then let's see if he manages to connect to RTT or to UART in order to capture logs and start troubleshooting. Here is not able to find West. The general allow him to look elsewhere than the current folder. West is installed. You should discover the way to use it. Yeah, even G-Link is installed. Don't always go in this direction. Okay. Let's close these UART terminals. So maybe he would decide to use UART and be able to use them and not find them blocked. So instead of doing this, let me guide him a little bit. Although this is not what the purpose is. The purpose is to let the agent find out how to do it. Maybe he will find it. Otherwise, if I see he's going around, then don't know why he's looking to rebuild the firmware. Idea, consult with Nordic MCP. As you see, the Nordic MCP returns this big MD files with some instructions from the different dev zone and documentation and so on. See how helpful it was. Find which NRF util. See, yes. Let's not interrupt him. Let's see if he reaches a solution on his own. Just something to note. All these interactions is token consuming. So at the end, we will calculate how many tokens this session consumed. That will be one of the key criteria and KPIs we'll be comparing between the two. Fail. Still not able to read UART. Yeah. He has elaborated a to-do list, main.c, by the fix in the VLE. So now he is falling back into analyzing only the source code. While the source code is compiling fine, it doesn't show any errors during the compilation. If he is able to find the issue directly just from the source code. So what did he find? I found the BLE bug in connected call valve. Advertising is never stopped when connection is established. This is not the issue. So now he's trying to, he corrected the firmware, is trying to flash, and is hitting issues as well. So he was not able to read logs. He could read the code. He could guess somehow the source of the problem. It's not the right solution, but it's fine. It's trial and error at the end, as long as he's able to do the full. Let's see. Actually, he's not messing up with my boards. Still not able to renew it. Again, I've chosen this particular bug because it's not the type of bugs that you can figure out just by reading the source code. So you have to be able to read the logs at least. I mean, the goal behind the Adsum IoT Coder is to be able to read the code, read the logs, and even use external things like a sniffer, like a power profiler for certain use cases, like spectrum analyzer, and in order to do the full, in the middle debugging, what an embedded developer would do. Hey, this is going in cycles. It doesn't seem to be taking us anywhere. See what's the summary. I completed the full debug cycle for your Nordic NRF and identified and fixed the BLE issue. What was wrong? The PIC was remaining in invalid. Why this problem happened? Connection instability, protocol violation, very general things, controller conflicts, all those. So the fix, what they did, added the BLE advertising stop. How did this fixes? How did they test it? We don't know. The change made, do a quick test then and see whether they solved it. So wait, let's refresh. We still have both boards coming up. Let's connect to UART in board 1, UART on board 2, them side by side, and then test it here. So the 52 is able to send to 53. Now 53, nothing to 52. Problem not solved. And I'll tell you at the end, because there is no straightforward way to show the tokens consumed in this session. They have a script calculates it. As you see, the context was almost full, 200,000 tokens. So it's full at almost 64%. This is the general coding agent. And yeah, at the end, problem not solved and so many tokens consumed. Let's now go back to the Adsum IoT Coder. I will prepare the ground again. I will restore the original code, flash it again on all boards, and then we'll come back to you. 52, which is central, sending to peripheral, it works. 53, peripheral sending to central, nothing. Okay, all right. Let's try it with the Adsum IoT Coder. First, to do it with Adsum IoT Coder, you go to your extension store, you find it, search it with Adsum or NRF debugger or coder, you will find it, you install it, then you go there. First install, it will bring you to this screen actually, and it will immediately show you that you are on Adsum free tier and show you your initial free tokens that have been allocated to your account, to your free account. Okay, you can immediately change it to an open router model, a different model, OpenAI compatible, or through open router or through other providers. Let's start with the Adsum free tier, just to show you how that it actually works. Get into this screen where you have two main actions or tasks. So the one that we are looking after is to debug live device logs. So you will stream RTT or UART logs, the code, source code, and then analyze and find the root cause of the problem that you are trying to fix. As you will see here, we will not even tell him what's the problem. He will figure it out, as opposed to the general agent. We kind of hinted him what's the problem. Here, we're not telling him anything about it. The second task here is, if you want, before looking into your detailed problem, into analyzing and debugging your code, if your code doesn't have the right logging code, like those, there is a best practice in the way you would put your logging, you enable your logging within your code in order for you to be able to troubleshoot, and in our case, for the agent to be able to efficiently troubleshoot. So we want to do this second one. We will try it with the first one, but in general, if adding this second task, if the problem is complex and you're not able to sort it just with the initial tools, that's a good way to augment the efficiency of your troubleshooting. So now let's start with a new session of debug. Just click there. Initially, I will just show you that it initially picks up the free tier tokens. If you click here, you'll see them decreasing. So at the first interruption, I could stop him now and move to my other tier, but I'll let him until my first interaction. So here he's asking me to approve him to read the prg.conf file. So here I will switch to open router and choose Haiku. Knowing that this is Haiku 4.5, it's not the latest Haiku, because there is in the list Haiku. So I would choose the 4.5 because I know its performance already. I disable thinking, and then just use that for this session of troubleshooting. Let's close this one. Also, let's close these two so he has access to UART, and just let him. See, he already used the NRF CLI. He has detected the two boards, and then he knows that there is device 1 matches the peripheral UART project, and there's device 2, which is the 53, matches the central device project. Okay, so let's ask him. Yeah, it's a 52 matching peripheral and then 53 matching central, although this is inverse actually. So you will see how when he captures the logs, he will realize that it's the other way around. Right now he's guessing that it matches that. Okay, because the central is the 52 and the peripheral is the 53 series. So let's capture logs from both devices. Put 60 seconds so I have the ability to also simulate some exchange data, so he can see that the data is only flowing one way. Okay, now he started capturing. Let's quickly go there, enable UART on both, okay, and emulate some data exchange. Here, no way, here, nothing. Okay, just so he could see it in action. Now, I'll go back to the tool, to our terminal. Okay, still 12 seconds. It's still capturing whatever logs there are. We selected 60 seconds. Usually 30 seconds is enough. You could put a custom duration depending on your use case. And now he's analyzing the logs. Let's close the UART. You see, here he figured out that the 53 is now peripheral and the 52 is now central. Now he's asking me fix the TF3 try logic in the code. So now he found out possible root cause for the issue. Log analysis, peripheral is this, central is this, root and initialization works fine. He's just going through the logs, connection flow is fine. And then the data transfer issue detected, okay, recurring pattern, send failed, receive succeed, send failed, receive succeed every 2 seconds. So that's when I was sending and receiving and not receiving on one side. So look at the source code, okay, warning is logged on BLE NAS. Blah, blah, blah. So error found, failed to send that over BLE connection, etc. Root cause and recommendation. Primary issue, the peripheral BLE write thread is attempting to send data faster than the BLE stack can transmit it on BLE NAS send failed. The data is silently dropped, not queued. Why this happened, files, etc. So this is his first hypothesis, and he is proposing to fix this issue. So you say yes and start going through. Here he is also, the fix he has proposed here is by updating the code on the peripheral side. So still, maybe this is not the solution. But again, this is how you troubleshoot. You try an error and you have a logic, you will reach your solution. This first try is proposing some changes, the peripheral code, and I would allow them. I can anyways roll back whenever I want. So now is also some pieces in the main.c peripheral. Flash the device. As you see, already found the right tools and is flashing. And is flashing the 53 series. I can see it blinking here. Now it's asking whether to capture logs from both devices. I would recommend both devices rather than just peripheral. Okay, 60 seconds, he's capturing logs. Let's go back to the devices, connect, exchange that so he could see it in action. It's the actual issue. As you see, the problem is not solved. This is enough. Close it. 24 seconds to go. Same as you see. Failed to send, received that. Failed to send, received that. See the problem again. Deeper than the transient connection. Then reveals the UART loopback feed. Okay, big things. What's working? Connection security, blah blah blah. HI. What's not working? UART echo loopback data received from central if like back. Add UART echo filter to peripheral. So the second one here, debug logging, is adding those debug lines in the code actually, so he is able to enhance programming capabilities. Let's do both. Add the filter and do the debug. Or sometimes if you doubt that it's the actual solution, just ask him to add the debug logs. I will help him add the right, hooks and codes so he could capture where the issue is happening. Now he's realizing there's something in central. At good time, the agent is able to find its way because he has access to that curated knowledge base that we inject dynamically with the Adsum IoT Coder. So now I have the context I need. Let me plan the two fixes. The fixes, giving me the right, be changing the code. Now, I cut this on purpose. I'm not here to make you sit through a full debug session. Full end-to-end debug sessions across multiple real-world scenarios are coming soon. Subscribe if you want those. It's free to try, no API keys, no account. Just search Adsum IoT Coder in your VS Code marketplace. Thank you.